Let's see what Whelen is up to in their recent patent application. A light bar with additional periphery lights for further functionality. The periphery lights can be operated through LEDs positioned behind the primary emergency lights of the light bar. The LEDs can transmit light through a light transmissive material to the periphery. These periphery lights can be operated independently of the primary emergency lights to provide identification during non-emergency situations or additional information for coordinating emergency response. Emergency vehicle light bars are typically made with series of light-emitting diode, LED lights, and reflectors to generate bright visual signals and to alert people in the area of the existence of an emergency condition. These lights are unused during non-emergency conditions and often cannot be used for any other function due to concerns with creating confusion as to whether the vehicle is responding to an emergency situation. Because of this, these lights cannot be used to alert people to the presence of an emergency vehicle that may need to respond to an emergency during periods of limited visibility, and based on their configuration, emergency vehicles are usually indistinguishable from vehicle to vehicle. With multiple emergency response vehicles, the activated light bars can result in a confusing scene of lights. In these situations, it can be difficult to determine which vehicle is coordinating the emergency response, especially in situations with limited visibility, where vehicle markings may not be readily apparent. Because of this, there is a need in the art for emergency vehicle lighting systems, including for use with light bars, that have lighting options outside of the primarily emergency signaling LED setup. The present invention is directed to a system and method for providing a light channel system to selectively transmit light from a light source to a desired light output location different from the light source location, while minimizing the area required to transmit the light. The light channel system may include one or more light sources, a controller to selectively control the light sources, one or more light channel components to direct and transmit light from the one or more light sources, and one or more housings or mounting components. The light channel component may be formed from a clear, solid material, or may be formed as a component with a hollow center and reflective internal surfaces. For example, the light channel component may be formed from an optical lens material made from a transparent material, such as acrylic, silicone, clear plastic, polycarbonate, glass, or fiber optic material. The light channel component may be configured as a light pipe or light guide and can be of different shapes and cross-sections. The light channel may have a source end and an emitting surface, with the source end positioned in proximity to a light source such that light enters the light channel. The light from the source is then propagated within the light channel, such as by internal reflection, and exits the light channel at an emitting face or surface. The light bar can also include at least one peripheral LED and light transmissive material, making up a lighting channel. The light transmissive material can be in visual communication with at least one source LED, the front periphery, and the back periphery of the light bar. The system and method may also include a light splitter. With the light splitter, the light channel source LEDs can be split to transmit to the front periphery and the back periphery. Light can be emitted from the source LEDs to the splitter, and then independently through the light transmissive material, making up one or more light channels to the different selected light-emitting locations.
In an embodiment, a system for projecting an image onto a surface includes a projector module, the projector module having a matrix of lighting devices. The system also includes one or more sensors, the one or more sensors configured to obtain at least one or more image parameters associated with the image. The system further includes a processor and a memory having instructions that, when executed by the processor, cause the system to receive one or more image parameters from the one or more sensors. The instructions, when executed by the processor, also cause the system to determine one or more image projection properties based, at least in part, on the one or more image parameters, the one or more image projection properties adjusting features of the projector module to display the image according to a selected output format. The instructions, when executed by the processor, also cause the system to cause the image to be projected by the projector module in accordance with the one or more image projection properties. In an embodiment, a method for projecting an image onto a surface includes receiving a user input associated with an output message of the image. The method also includes receiving sensor information associated with at least a relative position of a projector module and the surface. The method further includes determining, based at least in part on the sensor information and the output message, one or more projection properties. The method also includes illuminating one or more lighting devices in a pattern to display the image. Embodiments may be integrated into any fixed or mobile infrastructure, such as a vehicle, a street lamp, an overhead toll structure, a movable sign, or the like. Through this active solution, motorist confusion may be reduced beyond levels supported by traditional passive warning systems, resulting in improved traffic flow and greater overall safety for motorists, construction workers, and first responders. In at least one embodiment, systems and methods may be incorporated with first responder and/or Department of Transportation (DOT) operations. Moreover, when the projector module is attached to a vehicle, such as emergency vehicle like an ambulance or police car, a controller associated with the projector module may further receive information from in-vehicle sensors and data sources, such as wheel angle sensors, steering wheel sensors, door sensor, seat sensors, in-vehicle controllers, and in-vehicle computing devices. For example, in-vehicle cameras, wheel angle sensors, and/or steering wheel sensors may provide information indicating that the road ahead is curved and not straight. In such a situation, the controller associated with the projector module may be configured to modify the light output of the projector module, forming the image such that it matches the curvature of the road.